Hello and welcome everyone. In this video, we'll see a couple of techniques to hide code from static analysis using static and global initializers. And also how to detect this as well. These tricks can be used to create backdoors in other software or to hide malicious code outside of the main function. Let's see. In the second part of the video, we'll see how GCC generates and runs these initializers. Let's start with the first technique. By the way, source code for both of them is available in the link below. So here we have defined a global variable. It is initialized by calling the function foo, right? And the code is very simple, as you can see on the screen. Nothing fancy here. Let's go ahead and compile it. And it compiles without errors. As expected, the foo function gets executed first, then the main one. Right, let's open IDA Pro and open the file and then go ahead and analyze. The first function presented to us is main. Nothing really interesting here, guys. This is the foo function we've defined in the code. It is called by another function that initializes the static variables. This in turn is called by wrapper code generated automatically by GCC compiler. Let's see together what's next. More auto-generated code here. Alright. All starts with a reference in the init_array structure. This is the global initializer for the bar variable. Right. We could easily see how these wrappers functions present so many opportunities to hide code. We can use object dump tool to view all the sections of the compiled ELF binary and get the location of the init array. From here, we could automate the detection of any initializers hidden here. Alright, the address ending in 3DE0 matches IDA Pro output. We have a pointer to one initializer defined here. I think this is an interesting technique. Let's move on and have a look at another similar trick. The next one will involve a static class member. Alright, we define the class and inside a static variable. Remember, static members and global variables get initialized first. Foo variable is initialized by calling this bar function over here. Right, let's compile and test the order of execution of the two functions. Let's see together here. -wall flag turns on almost all the warnings. A good idea most of the times. As expected, the bar function got executed first before the main. Have a look again at the code. What can we notice here? We run object dump and get the address of the init array. It's the same address as before, right? We'll open the compiled ELF file in IDA Pro and see in this case where is the static variable initialized. Can we find it? This is the bar function over here, right? A cool trick to view the full call hierarchy leading to our function is to go to view menu, then graphs, then crossrefs to. Right. A bar function is referenced in the same static initialization and destruction function. From there, the same auto-generated wrappers all the way up to the init_array. Right. Let's see. What do we have in here? There you have it. 2 new methods to execute code outside the main function and a couple of ways to detect them using ObjectDump and DidaPro. That's all, guys. Thank you very much for your time. If you liked this video, please subscribe to our channel and share with us your comments. Cheers!